Now here in this period of algebra, we are going to learn operations on surds. In last period, we have studied the concept of surds, order of surds, also similar surds or like surds. Now, we study the operations on like surds. Now here addition, first addition of surds. Now here example is given. We have to add 7 root 3 plus 29 root 3. To add this 7 root 3 plus 29 root 3. Now here root 3 is common. Root 3 is common, take it out of the bracket. So in bracket remains 7 plus 29. And 7 plus 29 we get 36 root 3. So this is the addition. 36 root 3. Similar way you can do the subtraction, or you can subtract the surds. Now we take subtraction of surds. For example, simplify 7 root 3 minus was here 7 root 3 minus 29 root 3 is equal to, now here root 3 is common here. In bracket remains 7 minus 29. Sorry, you have to take, yes, 7 minus 29. So 7 minus 29 we get minus 36 root 3. Sorry, not minus 36, it is minus 22 root 3. Seven minus 29, that means 29 minus 7, 22, and sign of the greater number. Now multiplication. Example, root 7 multiplied by root 42. So root 7 multiplied by root, we can write this in under one radical sign, because orders are equal. Orders are both the surds are same. Therefore, we can write in one radical sign. That means 7 multiplied by 40. That is equal to this multiplication After multiplication, we will get here again we will 7 as it is. We can find the factors of 42. 7 as it is, and factors of 42 are 7 multiplied by 6. 7 6 are 42. That means 7 into 7. 49 multiplied by 6. Now 49 is a perfect square. So take square root of 49. Square root of 49 is 7 root 6. So multiplication is 7 root 6. And 7 root 6 is irrational number. Now division. Example. So this we can write like this: under root 125 divided by under root 5. Now here in both the surds order is same, equal. If order is equal, then we can write it in one radical sign, that is equal to under root 125 upon 5, that is equal to under root 25. 125 upon 5 is 25, and square root of 25 is 5. So answer is 5. So in this way we can add, subtract, multiply or divide the surds. Now rationalization of surds. If the product of two surds is a rational number, then each surd is called a rationalizing factor of the other surd. That means to find the or to convert the given surd in the rational number, then we have to multiply the given surd by another surd so that the product is a rational number. That means to find the rationalizing factor, to find the rationalizing factor of the surd. For example, root 2. Root 2 is a surd. So multiply this root 2 by other surd such that the product is a rational number. Now we'll multiply it by root 2 itself. Now this product is 2 and 2 is a rational number. 2 is a rational number. That means here Root 2 is a rationalizing factor of root 2. Root 2 is rationalizing factor of root 2. Now, we will multiply it by another rationalizing factor. Root 2 multiplied by root 8. So root 8 is also third. And root 2 is also third. And root 16 is equal to 4. That means product of these two thirds is rational number. Therefore, root 8 is a rationalizing factor of root 2. Similarly, root 2 is rationalizing factor of root 8. That means both the thirds are rationalizing factors of each other. Also, root 2 is that means both are the rationalizing factors of each other because product of both the thirds is a rational number. That means if the product of two thirds is a rational number, then each third is called the rationalizing factor of other third. Now, question number 1. Practice set 2.3, question number 1. State the order of the thirds given below. Now see here first. Cube root of 7. Cube root of 7, so here order is equal to 3. Order of this third is 3. Now in second example, 5 root 12. Here 5 is coefficient, it is not order. So here 5 multiplied by root 2 is here, root 12. So here order is 2. Fourth root of 10, that means order is 4. Square root of 39, order is 2. Cube root of 18, order is 3. Now question number 2. State which of the following are thirds. Justify. Example 1. Cube root of 51. Now see here cube root of 51 is irrational number. Because we cannot simplify this. Cube root of 51 is therefore it is a third. Is a third. Now example 2. Fourth root of 16. So 16, factors of 16 are 2 multiplied by 2 multiplied by 2. 2 2s are 4, 4 2s are 8, 2s are 16. That is equal to fourth root of fourth power of 2. That is equal to 2. That means fourth root of 16 is 2 and 2 is rational number. And therefore fourth root of 16 is not a surd. This is not surd. In this way, you can determine which are the surds and which are not remaining in remaining examples 3, 4, 5 and 6. Now we will take the third question. Classify the given pair of surds into like surds and unlike surds. Classify the given surds into like surds and unlike surds. These two surds are given root 52 and 5 root 13. First we will simplify, then we will determine. Now here root 52, we can simplify this surd. Factors of 52 are 4 into 13. Okay, and 4 is a perfect square and square root of 4 is 2 under root 30. Now see here, in these two, 5 root 13 and 2 root 13. So here, order of each surd is 2 and the radicands are also equal. Here radicand is 13, here is 13. Radicands are also equal. Both the surds have equal order and radicands are same. Both, therefore, these two surds are like surds. So the given surds have equal order and their radicands are equal. Therefore, these surds are like surds. Okay. Now second example. Now second example. Root 68 and 5 root 3. Now see here, root 68. We will simplify this. 4 into 70. That is equal to 2 root 70. Now 5 root 3 and 2 root 70. In these two surds, orders are equal, but radicands are not equal. Here radicand is 3 and here radicand is 17. So orders are same but radicands are not equal. Therefore, these two surds are not like surds. That means these are unlike surds. And therefore, unlike surds. Now, from question number 3 remaining, you compare or you determine whether like or unlike surds. Now question number 4, simplify the following surds. Simplify the following surds. Example number 3, root 250. Now we will simplify this. Find the factors of 250. 25 multiplied by 10. 25 10s are 250 and 25 is a perfect square. One factor must be perfect square. So root 25 is equal to 5. Square root of 25, 5 under root 10. This is the simplest form. In this way, you can simplify the remaining surds. Now the question number 5, compare the following pair of surds. Question number 5, compare the following pair of surds. First example, these are the two surds are given. Now squaring both the surds. Seven root 2 bracket square is equal to, now 7 square is equal to 49 and square of root 2 is 2. That is equal to 98. And now square of squaring 5 root 3, we get square of 5 is 25 and square of root 3 is 3, 75. That means here here 90 is greater than 75. So 98 means square of 98 means square of 7 root 2 and 75 is square of 5 root 3 and therefore 7 root 2 greater than 5 root 3. So, remaining examples from question number 5 you solve. Now we will take question number 6, simplify. And in that question number 6, example number 2. Example number 2. 9 root 5 minus 4 root 5 plus root 125. Now here, for addition or subtraction of surds, the surds must be similar surds or like surds. Now here order of each surd is equal. Order of each surd is 2 equal. But radicands, are not equal. Here is 5, 5 and here 25. So we will simplify this so that the radicals should be equal. Nine root 5 as it is. Is equal to 9 root 5 as it is minus 4 root 5 as it is plus. For simplifying this, find the factors. Two factors such that one factor is perfect square. That means 25 multiplied by 5. 25 5s are 25. So here 9 root 5 as it is minus 4 root 5 as it is plus square root of 25 is 5 root 5. Now all surds are similar surds. Now we can add and subtract here. Now root 5 is a common. Take it out of the bracket. Now in bracket 9 minus 4 plus 5. Now 9 minus 4 is equal to 5 and 5 plus 5 we get 10. So answer is 10 root 5. Question number 7. Multiply and write the answer in simplest form. Three root 12 multiplied by root 18. Now both the surds have equal orders. So we can take both numbers in a one radical sign. That is equal to 3 and root 12 multiplied by 18. That is equal to 3 root 12 multiplied by 18 we get 216. And now this is the multiplication of surds. Now we will simplify this. We have to multiply and then we have to simplify. We have to write in the simplest form. So find the factors of 216. That is 36 into 6. 36 into 6 is equal to 216. 6 6 are 36, 3, 6 are 18 plus 3, 21. Now 36 is perfect square, take the square root of 46. 36 we get 3 as it is, multiply by square root of 36 is 6 root 6. Now 3 6 are 18 root 6. This is the answer. 18 root 6. Question number 6, example number 1, see again. Question number 1, 3 root 12 into 18. So here multiplication is 12 into 18, 216. So here we get 3 root 216. Now again we will simplify this. The factors of 216 are 36 and 6. Now 3 as it is. Take square root of 36, 6, under root 6 as it is. And 3 into 6 is equal to 3 6 are 18 root 6. This is the simplest form of this multiplication. Now remaining examples we can solve. Now next is question number 8. Divide and write the answers in the simplest form. Now divide and write the answers in simplest form. Example 1. under root 98 divided by root 2. So we can write this under root 98 divided by root 2. Now, both having equal orders. First we will simplify this. So factors of 90, 49 into 2 upon root 2. And square root of 49 is 7 under root 2 as it is divided by root 2. Now here root 2 gets cancelled. The answer is 7. So your answer is 7. So in this way, using the same method, you solve remaining examples of division. And now we will solve question number 9. Rationalize the denominator. Question number 9. Rationalize the denominator. Example 1, 3 upon root 5. So that means to rationalize this denominator, at the denominator there is third, that means irrational number. So we have to find the rationalizing factor. We have to multiply it by the rationalizing factor so that the denominator will be a rational number. Now see here, root 3 upon root 5 is the given example. To rationalize this denominator, we have to multiply it by its rationalizing factor. So we can multiply and divide both numerator and denominator by root 5. 3 multiplied by root 5 upon root 5 multiplied by root 5. That is equal to 3 multiplied by root 5, and here root 5 into root 5, that means under root 25. That is equal to 3 root 5, square root of 25 is 5. That is 3 upon 5 root 5. That means here denominator is rationalized. The 5 is a rational number. So in this way, remaining examples you try to solve, and also solve all the examples, all remaining examples from practice set 2.3.